Hey everybody.
Hi, Rich.
Okay. Oh wow, we've got loads of people here. Cool. Um, it was a mistake setting up the waiting room. Now I've got to admit everybody. So this is kind of a bit of a science experiment, and we're going to learn from these kind of things as we go along. I think, but if it goes well, maybe we'll do more of them. Cool. Okay. Just wait another minute or two to see if anybody else needs to be admitted from the waiting room bit. No? I mean, what a great turnout. Um,
Check.
okay, let's get going. Cool. Okay. Welcome to the first Friday sessions. This is a bit of an experiment. I decided to put together since we're all out of work at the moment. Oh, more people still waiting to join. Setting up the waiting room was definitely a bad idea. More for anyone? Okay, so like I was saying, welcome to the first Friday sessions. It's a bit of a science experiment and something we threw at the Facebook page, the Disguise Facebook page, to see if there would be any interest in while we've all got a little bit of downtime with the coronavirus. So I hope you're all keeping safe. And basically, I've put together a bit of a presentation to share with you on my UV mapping workflow. Once we get to the end, maybe we can sort of do a bit of a question and answer, and if anybody else has got anything to add, that'd be pretty cool too. This is waiting room things.
Your call is important to us. Please continue to hold. An agent will assist you shortly.
Ito nakasombrero ulit. Hindi ka naman nakikita.
Nakita.
Any more for any more? Okay, cool. Awesome. Okay. I can see there's some chats popping up, and been muted. There you go. UV mapping. Thank you for joining us today. And as I was saying, this is going to be a little presentation on my UV mapping workflow. Once we get to the end of this, if anybody's got any questions, we can kind of do questions, or if anybody's got sort of any insights in terms of their own UV mapping workflows. It's one of those things that there's definitely multiple different ways to do it with multiple different pieces of software. And I'm just going to show you one route today. So we're not going to be able to cover everything. My little agenda for the day. I kind of already covered the introduction already. UV mapping, and this is kind of the subjects that we're going to go through. This whole thing is kind of aimed at those people who kind of are starting to use Disguise or starting to use other media servers, and these last few people. Okay, that's becoming distracting, so we might just have to let the rest of the people watch the record. So this is aimed at those people who are kind of new to Disguise or new to media servers, and are just getting into creating their own 3D models and UV maps. We're kind of going to head through all these different subjects, and hopefully you sort of will have kind of a basic to intermediate understanding by the time we've got through all the rest of this. There's probably some higher level UV mapping stuff that we're not going to get onto today, and there are definitely some good tutorials out there to learn more, or maybe we can make another session in a few weeks' time where we do some more advanced stuff. But I think it was worth just kind of covering the basics. Right, so we're gonna start at the top. What is UV mapping? So UV mapping is it's the best way to describe it is geometric nets, which you might have studied at school. It's taking a 2D representation, which you can see on the right hand side of my screen, and we're gonna map that onto a 3D model. So the 3D shape in order to okay, so this is important is in 3D, in 3D media servers like Disguise, it's in order to be able to get your content onto your 3D objects, you need a UV map, and there's kind of no other way of being able to use 3D software without negotiating a UV map of some sort. So that's why this is important and kind of useful for our kind of workflow. There's kind of, let me have a look at my notes straight into. So now we've discussed, we're going to look very quickly at how, and then we're going to dig a little bit deeper down of generating those UV maps. So 3ds, so 3D softwares that you can use. The one I'm going to show you today is 3D. I tend to use most in my workflow. The Cinema 4D, Blender, Maya, ones that you can do, and it would be just impossible to kind of show all of those all at once. But hopefully some of the techniques that we're kind of going to go through today will be useful for whatever 3D software you use most. There might be, if you don't choose to use 3ds, it might be a good jump for your particular software. So objects that we could make is a 3D cube. Just going to see, this is going to be a 1 meter by 1 meter by 1 meter cube, and if I export this, bring this into Okay, so for disguise, there's a few things we should know just right at the basic level from exporting a simple cube and getting it into the software. Before we even get to the export process, the first one to think about is scale. I've set my cube to be a meter by a meter square cubed, and it's important that when we export this, that it keeps that scale fixed scale, which is meters. So if I go into unit setup, meters, so my scene is set in meters, and I also go to the system unit and make sure that's set in meters. So now when I take my cube and I export it, this object is going to be in meters. If I didn't set this, then when we get the object into disguise, the cube could be really, really big or really, really small. And neither are active to us. We want everything to be scaled the way that we see it in the real world. And that's kind of the key to making 3D objects work in disguise, is making sure that your real world map. I'm making a new project here, test cube. I right click the project, click. This is basically my, if I don't make it go away, this is basically my D3 project. So everything inside this is my D3 project. And if I needed to copy this over to running on my, if I wanted to copy this project over to a rack machine to like take it on tour or put it into a theater, everything that I would need to make that work would be inside this project folder here. If I open that and head into mesh, and I'm going to grab the cube that we exported, put in there, load disguise, and running would be inside this project folder here. If I open that and head into mesh, mesh is where the models live, and look, a projector and a surface. Just tend to remove these right at the start, and add our cube as. So we can next to our puck, getting right that our let's say, and fortunately our cube's correct. We can set the resolution, and we get a bit later about UV maps and bring. So this. So that is the of taking a model from your 3D software. In my case, 3D a new project. We've opened up the object, added mesh, added our cube to the project, which we just added to the scene there. How you bring 3D objects into D3. Bit of a primer really, as we're going to kind of go down the UV mapping rabbit hole now, and it seemed like getting to how to get 3D models in the first place. So here's a demo project that I created earlier. Get back to slides. Bring custom models into disguise. That's what we just covered. So correct UV mapping. The thing about UV mapping is that it really depends. It depends on a number of factors, and this is why I think it's quite a difficult subject to cover. Is that depending on the location of your audience, the video technologies that you're using, the content workflow that you're using, there's loads of different factors that will govern what the best way is to create a UV map. And we're going to cover all of those today. As we looked right at the beginning of this talk, like one of the most, if we're talking about a cube, this is probably one of the most obvious ways to think about a UV map or a geometric net. So here we go. here's some examples to kind of to back what we're doing. So if we export a model from the vast majority of 3D packages, each face covering the same UV space. Look, we have this cube and our media. Move this. Okay. The media is going to map exactly to the same, which is fine if that's what you want to do. The question is to achieve in terms of can this work for your show? An example. This is the one that I was showing you in our slide here. It's the same, basically the same cube, still meter by meter, but the UV map that we've generated for it is like this. So each one of the 6 faces has its own unique UV space. So with here, each of the 6 faces has the same image, is copied all the way around the cube. We've got unique UV space for each face. So now we can have content that's differently mapped wherever we're looking on the cube, which tends to be a little bit more controllable. If we move on, this UV map that we've got here is also a valid UV map. If we have a look at this in disguise here, it is showing content on each face uniquely. It's the same. Oh, if we set that to 1080. Example 1 cube over here, but the actual resolution of the content that we're seeing, because it's occupying such a smaller amount of UV space, gives us a much lower res result. And also, it's really wasting pixels. If you think your media server has to process this entire UV space just to get these pixels, versus a map like this, which is a little bit better optimized, this is a much better way of working than this. However, both are still valid and working UV maps. So when I say it really depends on what you're trying to do, there are definitely ways in which UV mapping objects kind of doesn't make sense, like this. This will still get you pixels onto your model just as this way will. Okay. Oh, we skipped a subject. So this is my next example. If we go over to example 3, so same cube again, different UV map. This UV map here is the one that we're looking at, and this is also a valid UV map, but it essentially doesn't work to actually map the content correctly onto the model. Although some faces kind of work, we're also seeing big areas of unmapped space, which is because all the different faces are scaled outside the bounds of the UV map, and we're not able to actually accurately map the faces when we bring it into disguise, and we're using that map. So again, a bit like this map, this one is technically a valid UV map. However, it doesn't really help us out in terms of mapping our models correctly when we get it into the media server. Moving on to example 4. So what I'm saying when we're talking about these 3 maps is that there's multiple different ways to do this, and no one way is the right or the wrong way, but there are certain things that you want to avoid. So you want to avoid not making the most of the texture space that you've got, and you also want to avoid overlapping the edges of the UV space so that you're not getting to see all of your content on your model. And this process of setting out your UVs in a way that makes most sense and gives your media server the best opportunity to use the texture properly with your model is the process of texture optimization. So in example 4, we've got here, same 1 meter cube. This time we've generated the UV map which has no empty space, and each one of these squares is occupying a much bigger amount and therefore higher resolution than any of the other maps we've seen before. And if we just say quickly compare this to example, it might be hard for you to tell on a web stream, but even from here, it's quite easy to notice that there's a lot more pixelation around the numbers on example 1 than there is on example 4. That's because we have got we're covering a much bigger texture area with each one of the faces, and from a media server standpoint, you've not got any dead areas. There's no pixels here that are having to be processed by the graphics card that aren't going to be used for outputting the content that you want to show. So think about when you're creating your UV maps, how best to optimize your texture and fill your UV space with your UV islands like this. There's one more example here. So one of the things about our original UV map that we created, if we skip all the way back to this slide, is that there's a lot of empty space around our UV islands that essentially has got to be processed by the server that isn't being used. So if we look here, we've created a UV map which still has some dead space, but at least we're not seeing the dead space at the top and the bottom. So if it makes most sense for you to lay your map out in this format, then this would be a better optimized UV than the one that we created in example 1. So I guess the question is if dead space is bad and we want to try and optimize the amount of space that each face gets, why would we ever do this and not always this? The reason for that is if we, again, now I'm going to join these two examples together. So if we look at these two cubes, the faces are mapped differently to try and work out which face needed which output on this map. And it kind of proves a point. If we use a map like this, each of the adjacent faces are connected to each other. So if you see the 1 folds over into the 6, go over here, 1 folds over to the 6, and that's adjacent to the 5. Now, if we look underneath, model up, the 5, the 1, and the 6 are all connected, and the 5, the 1, and the 6 are all connected here. So whilst this is a much better optimized map in terms of utilizing the processing power for your media server, this one might be a better map in terms of being kind to your content creators and having your UV laid out in a way that makes logical sense for the way that your content team is going to generate the content can be more important than maximizing the sort of dead or minimizing the dead space outside of the used texture. And so that kind of shows when we're optimizing our textures for UV space that whilst this might make a little bit more sense for us as media server operators, this might be better for your content team. So it's a case of weighing up the pros and cons and having a conversation with your content creators about what's the best way that's going to work for them. I don't think any of these decisions can be made in isolation. And it might be that your content team is very happy to work in this way. The content might be living inside each of these faces on its own and not interacting with the other sides of the cube, which would make this a really good map to use. But it's being aware that whilst there is no wrong way, understanding the reasons why you would choose one map over another, and what the conversations are that you would need to have to kind of work out which one was the best for you. Once we've talked about texture optimization for sort of single models, which is what we've got here, each one of these is brought into Disguise separately. We look in our stage view. We have models with separate UV maps, and along our timeline we have separate video modules which relate to each one of these objects. We haven't a resolution between these because that was kind of the point of this subject, is to kind of show that's kind of bad and how that will happen. If we move over to here, we can start, or some people call it, this comes really important outside for computer. And if you and character being a significant your character, it would be quite jarring, and this is why texel density. I've got two spheres here. One, so this is 2 meters in diameter. Because your texture model, if you use the same texture, two models essentially of the same, find that your texture starts to scale. Squares here, the squares here. So when you're generating, you kind of have to be more the size of your hand to the that's going to happen. If I take my second sphere, resolution of this colourful squares are roughly the same size, exactly. This is which is generally a whole stage, that your models and your modelling or stress your stage. That's the thing. I've got another set of models over here that I'm going to use to essentially demonstrate the importance of laying out your UVs correctly. Our square and our pyramid, roughly the same texel density. This guy is, not only is the texel in terms of the squares are much being laid out, make it near impossible to create anything interesting on this. If I show you what we're aiming for, same 3 models over here, and then same size. And with our torus here, the UVs are in a way that makes it much easier for content creators to interesting and lay their content out in a way that is going to make sense when they. So cool. Got one more guide to show you here, which is here's a little bit this morning. This has been UV mapped the same way that all the cubes are, significantly more complicated than the cubes that we were using with ES now, and look at the different map and the UV maps of our texel density demos, how that works. And loads of chat stuff. Can I explain what a texel is? That is an excellent question. Best way to think about it is the resolution of the pixels. Go back to our spheres. We want the pixels to be packed with model in your scene. When same texture models, essentially each one of these pixels is densities are matched. If we go original, this is which is on Sphere 2, size of the which playing the computer game, allowing for your audience to have versus another, or what this out into the real world, and we're using this on LED. About matching the resolution through your 3D scene and world, so that everything, and if I from the first sphere to the second sphere, they would essentially look at the same resolution thing than one thing being. Okay, questions at the end. So we've kind of jumped over some little bits as we've kind of gone through the Disguise project demo. So let's grab a few of our models and see. Okay, so this was the first describe the importance of keeping the resolutions the same between each, like that. So in 3ds, the way that you access the UV is by adding by doing the files list. Has a UV map that lives with it. If you were to, so this is the model. If you were to open an OBJ, this is basically on code level. On a code level, because you've got here is each of these. So is going to vertex mode. Here we go. So each model, 2 points together create an edge, red guide that you can kind of see there, and then once you've got 3 points, polygon, which is, so that is like the described in the, is each one of the a coordinate here, a whole load of coordinates. Remember which one? Your U vertex normal. So there's basically a set inside the model. All of the parameters get stored kind of. So in the OBJ, all the numbers that real model. So if I was to have let's maybe, if I was to make another model here, if I joined these two sets of models together, I would have to have a second UV map. I select this kind of what this is your, and is kind of what at the start of the talk when we were looking at the UV model, the UV textures and the shapes like this. The way that you in your UV space. These are all of your model. How this is how between the 3D shape was to maybe grab one of these. We're able to where we're going to apply the this one, and this was the kind of depth. We've got that bit over this bit. Difficult for your creating the content when they're rendering these pixels to say here. My shapes a little bit like this one kind of make a little bit more sense when you're doing generating your content. I open so this is that set of models. So one of the things about being able to edit your UVs is you need to mod the UV map for the one that are all connected to each other. Easy for your content team to understand through this part of the where that relate to. The rest of them are optimized, but has been the size of the rest of the to sort of use so we look and I'm getting a bit off task here. Okay, cool. I'm going just going to check some. The remaining part of this kind of talk that I've laid out is going to show you the way to generate UVs, or a couple of different ways to generate UVs for different types of models, and to see if there's any questions. Cool. Oh, sorry to hear that the audio is not going well. Okay. Okay, let's quickly cover this one, and then we'll move on to showing a few different ways to actually generate UVs. How do we generate the side of the sphere in Disguise? If I go to here's the texture that's being applied to models in the. This was being shown at 100% and 2 second, which is why on the second stretching the Photoshop texture checker was one, so that one. So that, because we need for basically be models. I think that we probably need to draw here at your the use over your model space. This so is well. With the okay. So size of your object when you scale. So if we just imagine that square model, this is always so if we size of the textures essentially and bigger and bigger and bigger, covering it's important to your machines when you are generating. This is somewhat easy, simpler shapes. So probably the easiest way to demonstrate this is. By 16. Cool. Okay. So when talking about textile density or machine scale, it's sometimes best to kind of decide where what the scale of the pixels is going to be for your entire project. So if I've got a simple plane here, which is 16 meters by 9 meters for easy maths. Let's grab a calculator. Basically, a reasonable scale for pixels on pretty much most projects would be 5 millimeters. So if we do 600 in millimeters divided by 5, we can work out what the resolution of our texture needs to be by setting this machine scale or textile density before you start working on your texture. 9,000, so that's 9,000 millimeters divided by 5 is 1,800. So if we grab this guy, we go to unwrap. 3ds has generated to see that it's correctly mapping the model because I'm selecting and they're correlating to the correct part of the model. If I now render the generated here, which is 30. This is going to give us a 69 texture with 5 millimeters pixel pitch. So so let's say that we have some more screens in our show. So I'm going to generate another. Let's say this one is 6 meters by 6 meters. In order to keep the pixels the same size, the same math. So 6 meters in millimeters divided by that. In order for these two screens to look the same resolution, to be 1200 pixels by 1200 pixels. So I'm going to go here, the UV unwrap, and then I can primitive generated my UV for me. If I go to the number that we came up with, 1200 by 1200. We now take an export selected. Working export selected. OBJ. There we go. Just one model export there. So we need to pop back and check out our numbers. So this guy, 1800. This guy was 1200 square. Create some content for these. Be identical because we matched those sizes when we generate these two models. So set the content to be pixel perfect to be able to see that content that isn't scaled at the same size. So 2 pixel map from 3ds. That's generate content inside of these. Then these would be pixel. Okay, cool. There's lots of questions. Okay, so great. I'm not sure there's to talk about. If you're already made at, for example, HD 1920, there isn't a significantly larger screen. What I was just the way like a fixed measurement would be 5mm square. Take that and extrapolate out to different. If every pixel on site is the 3 by 9 screen, so 3200 by 1800 is only 1920. Starting at a different point where your scale is or what your texel size is. And so, there you've got per meter. Like my brain's. Brain just. The mistake I made there was that the total pixels are millimeters by meters. That makes sense. So in millimeters for pixels, you also need screen size. If the base content is C and yours is 16 meters, you're going to be 8.3 millimeters to scale that on to, I don't know, another, let's say, example before, doing 6,000, which is our machine scale, the 6x6 square, 22 pixels square. Instead of start scale and screens in your venue, the size of your largest content to essentially. See, I'm sure I saw performance difference using trial, or does it not matter that much? Disguise bring in doesn't really matter. You'll end up if you want to control then you can attract it won't really. Last couple of bits kind of give up on this is share a couple of different ways of generating UV maps. So camera maps. So at the moment, certainly when we've been using primitives, the UV has been generated by the 3D software. If I take one of these models and we look at the UV map, this has already been created by 3ds when we created this relate to model and else we might not have we can UVs in 3ds by using the projection. Certainly for a flat shape like this, using action probably makes the most sense, which is basically polygon normals, which if you think of each polygon, a line center factly dictates which way it's facing. This is facing the direction flat planar projection. We kind of in direction that they are facing out of the model. If I get rid of this, open. Yeah. Okay, so this is possibly the worst production design the world has seen. But what I've created here prior to this little demo is like a geometric set, which I've got a little guy, These have all been created in 3D by me. If we add the unwrap modifier to each one of these, have a look here. Anything really meaningful. So if we were to apply the one I was using in Discovery 3D Studio Max, this model, we just sample it of UV space. We grab any of the other set pieces, none of them have particularly valid UV. The demo here is a method for generating UVs. I was talking about before. If we imagine all of the facing probably somewhere, we hit the planar map, all the polygons, and we get of the model face. Fortunately, it's back to front. Kind of face outwards into the room. You can see the diamag was generated by that normal. What I'm going to attach all these models together because it's going to make our life a lot easier very soon when we do it. And then into the scene. So another way, aside from using projection to generate, is to use a camera, and this is really commonly used to create like a hero position, a place normally kind of is the best looking view of your show. I'm going to render settings, just set the resolution of this camera. We'll make this HD just to make it easy. Cool. I'm looking at the extent of to make sure that all of our model is kind of held within inside that. And if I grab the model and UV map modifier, I'm going to say camera map. Camera. Then on top of that, we can apply, and what we this is a way to. This is a really great way to point of view. You can hand content creators. They can render their content onto in exactly the same way that you generate. The disadvantage is to basically of UV space. So we get if you here and here that the where that sit there, we're going to and if we have this mapping by the two models, which depends doing may or may not. We're never really going to see this part of the set be okay, but it's just sort of mentioned a little bit of a pitfall. You just have the location, so we might any rail with left and right covering the whole space. This is of generating your UV. I'm going to import. Oh my goodness. So earlier. rotate this, get rid of my checker model again. This is quite a nice but complicated model of a range radar, UV unwrap modifier. So model hasn't, but is kind of for now the scope of we could go through and each part in the way that we were earlier. However, if not from this angle, because this is where your camera's going to be or going to be, using a camera map way, be able to generate UVs for camera map. I'm going to pick the camera again. And we have the UV. It's kind of because the car in the editing. But this could be enough to generate. You have to do because the which is to say camera was 16:9. Render this template back at our camera, and now with as so. Probably worth thought this. Mistake. There's a white camera map like this, so. As we back into Skies project, this is the model that we just generated. This is our. So let's create a little bit of space for ourselves. If I set this to be the resolution that we and as long as we are this kind of work, unfortunately we're seeing the backside of the model through it because that's the way UVs were generated, but proper content creation sort of in 2D space would allow you to, the disadvantages of using camera maps, while it works very well sort of fairly flat shapes like the set design that I got a 3D model and we're looking at it from the place where we generate the camera map for. Everything's a bit of a lie and we don't get, I mean we've got lots of texture stretching there, so it's to using camera maps, these, but cheap hack that can kind of be used, if the location of your audience and making it a TV shoot or something like that. One last demo, and then we'll open to questions. And so that was camera mapping. Here's I downloaded this morning. A French resident spline mapping. So snap a line that works its way all the way. If I do snapping to the corners, so now I look at my scene. I've got my model and I've got my line, my spline. Now if we UV map here, we've got spline map, and I can because it's not a. I tend to. We want to unwrap that. Now we want to unwrap that again. Working as it did when I was. I've made a fool of myself there. Let's create slightly better demo or slightly different demo of using spline map, and maybe I can make that work and share the working file when we get the end of this. So if I just generate sort of an unusual shape like that and extrude it. So I'm going to extrude that. Let's say. I'm creating a copy of the line, but our shape that we're going to be mapping, and also the line that it was generated with. We've generated all along a set of UVs follow the contour of the shape. Which is to say that if we were to basically try and use a or something like that to generate the UV, the accuracy or the using flat projection, the ends of the model where which with pixels and a little demo with French house buildings are definitely one of the can be kind of really helpful because you can follow the outer facade of a building. Perhaps I'll try and make that work, and when we share the project files at the end of this. So we're going to wrap up. We've looked at camera maps. We've looked at spline maps. All I've got to say now is that's kind of the end of the talk. It's been a bit more of a bumble than I wanted it to be, but I hope you've learnt a few little tricks out of it. I've set up a Facebook page to share the record from this and the project files, and also to as any further discussions we want to have after that, and not sort of spam the Disguise page. If you are looking for more training for Disguise, go check out Chet's doing something similar. This is his YouTube channel. Go search Chat with Chet. He's done a couple of sort of basic Disguise fundamentals, and there's also the Disguise are putting a lot of effort into moving their training online. So there's you should check those guys out as well. I'm just going to check a couple of questions. Cool. Okay. If anyone's got any more, can I drop those links in the chat? Yes, I absolutely can. Because they grab off the screen. So this one is Chet's channel. So based on the two UV maps for separate screens in different pixel resolutions, how would you pass content over the two screens without using different videos? Good question. Can you rotate UV without it changing? Okay. try and answer Jacob's question first. Based on the two UV maps, how do you pass content over two screens without using separate videos? In Disguise, all the different types of UV maps that we've been talking about today, they're applied by using a direct mapping type, which is to say that the model is going to directly apply the content using the UV map. If I bring back my two screens, I think these will probably be the best way to demonstrate this. Find myself a little bit of extra timeline. Guys, patterns. So these are direct maps, and if I say if I just apply the content would be applied to the model, which is the flat screen, using the UV map, starting top left and moving down to the top right. Over these two screens, using the same pixel density and without using two different videos. What we can use is Disguise has some built-in mapping types that override the UV. So if I create a parallel map, so these are them. Grab one of these. What this does now is I'm going to set this. You add the screens that you want to work in this map. Set the resolution of your content. Then I'm going to turn the aspect lock back on and open this back up. So now I'm moving. You basically pushing the parallel sort of way, which is the content will kind of map onto, and it uses the because you've got this sort of unified. So if we scale that up a bit and then escape out of that, now we're using one video to map over these two. This isn't particularly nicely done sort of setup, but you could generate 2D content or even 3D content in a way that would sort of make sense to sort of map these two. So it will be worth checking out some of the other it has that does override the UV map. I think getting into all this kind of stuff is beyond the scope. You know, today's session's already been pretty long. So hope that helps. Cool. Okay. Can you rotate the UV without changing the orientation on the object? The UV basically governs the way the pixels are mapped on the object. So if you rotate the pixels on the object are going to rotate too. So those two things are kind of one and the same. Are texels for content creators determine the resolution to produce the content, or are all UV maps normalized by one? Really good question. It's matching your texel sizes is the same size and resolution across all the different screens in your venue. Not all UV maps have to be normalized to 1 by 1. That is kind of the, I would say, the slightly confusing part of the way is that UV space. So back into our spline map. If that UV is absolutely the right ratio this object to be. It's incredibly wasteful because we're throwing away the pixels top and bottom there. The UV space, and we render that out. you're filling the UV space, but all your pixels are going to be straight. Square shape doesn't represent the shape of your model. The way that you need to generate in non-normalized UV space. Quickly, I mean, this will not be accurate at all, but I 12, and we know because we generated this 10. So 12.2 to 1 ratio screen. So if we so we make 1920 by 157. So this would be in roughly at the right ratio. Properly, we'd have taken one of the polygons exact length of this shape that quickly for the purpose. B is that when you're looking your UV space rotation of pixel map is going to be non-normalized space. To unnormalize, bringing in, save this out to this. Okay, so if I here, so now my UV editor, I've kind of look at this when we're rendering our content to it, and the way by generating this first. If you aren't able to generate this, the way to make your template in Photoshop, and then you have your pixel templates, and you can map your reverse UV mapping. But perhaps that's something if we do a more advanced session. Cool. Best examples for UV maps would be to check game prop texture UV maps and any sort of tutorial on bringing things into disguise and a bit of a primer on UV. But if you can find any tutorials or anything like that generation, then that would be really good to look up and to spend some time researching. Cool. I think that's it. Thank you for everyone for watching, and if you join the Facebook group, take care, guys.
Great work, Rich. Thank you so much.